Welcome to the first tutorial on this channel. Today we are going to look at the topic point of interest in Godot 4. If there will be changes in Godot 4 about this, I will post an update. You can assume that because I use this technique in my game Legend of a Soul Hunter. First, what is point of interest? For those who already know what point of interest is, you can skip to the next chapter. For everyone else, I would like to briefly explain what this is all about. Point of interest is a subcategory in inverse kinematics, which is used in many games. The most well-known application of inverse kinematics is the correct placement of the feet on the ground. If there is any interest in this topic, post it in the comments and I will show this as well. But now, back to the actual topic. Point of interest is about the player, NPCs, enemies being more engaged with the environment. The main focus is on the head, which turns to a point which is interesting. This implies the dynamic turning of the head during gameplay and not in cutscenes pre-animated scenes. For example, we walk with the character through a world unknown to us. We don't know what all we can interact with and don't want to target every single object during free exploration and hope a little text pops up explaining that we can interact with it. Instead, we can use an area in front of the player that recognizes all points of interest in that area and turns the head to look at it. By giving it a prioritization or a certain behavior pattern, we can now decide what to focus on. This technique can be used to make it clear to the player without text whether something is dangerous, such as a project flying by, or to give hints that you can interact with an NPC or with an object in the world. For example, if you have a grappling hook that you can hook onto a branch of a tree. This all becomes much more obvious because the character is looking at it. It also looks much more natural than, for example, simply highlight all interactive objects. Let's take a look at a few examples from various video games that may or may not use this technology. And afterwards, let's briefly discuss whether it would have made sense in the respective game or not. Hitman 3. Hitman 3 seems to use point of interest for some NPCs. This is not really the case for the main protagonist. He doesn't look at point of interest even if they are specially marked targets or one of the targets that you are supposed to take out. The fact that Hitman himself doesn't show any human traits through this makes him seem a bit lifeless and out of place in the world. Wouldn't you rather notice a person who behaves against natural human behavior? Mafia 2. Mafia 2 is a rather older game, but it already uses this technology. Unfortunately, only for selected characters and not for every NPC or event. For example, he does not look where something is broken next to him, even though it is a scripted event. Likewise, fights seem strange when you pay attention to where the character is looking. Since the two fighters are always facing each other, it is especially noticeable when one of the fighters is on the ground. Saints Row the Third. This part of the series is a bit younger than Mafia 2, but unfortunately doesn't use point of interest at all. The people are well animated and often look in the right direction, but not intentionally. Saints Row is a game that becomes really funny through chaos. As you can see in the clip, I cause a bit of chaos here or bump into people. They hardly react to the player and the player himself hardly reacts to what he has done. Unfortunately, this seems a bit out of place. Legend of Zelda: Breath of the Wild. This game uses points of interest a lot. Traveling through the world and exploring feels much more alive in this game thanks to the points of interest that Link is looking after. This is especially noticeable in that the NPCs interact with Link through it and Link with them. Imagine walking through this world like a puppet without paying attention to anything. The game would look very unnatural and the playful areas wouldn't work as well. Xenoblade Chronicles Definitive Edition. This game also uses point of interest. Here it is not used everywhere, but especially in situations where a conversation could arise. Thus, the world seems more real here, and you also feel this depressed mood when they talk about the suffering that the characters are currently experiencing. Luigi's Mansion 3. Points of interest is also used in this game. Here it is used so well when Luigi is scared of something or something else happens. It immediately makes Luigi look much better with his very well animated animations. Whether he is just startled or discovers something doesn't matter. Luigi looks towards it and that's why everything seems so correct. By the way, the environment does the same with Luigi, for example here with the security camera. In summary, not every game necessarily needs points of interest, but many third-person games have it integrated. It is an addition which can be added by the developers. It is not necessary if you have no added value from this functionality or it improves scenes. It also works only when you look at it in the third person. Try to see if this technique is used in the current games you play. Can you explain why a game uses this or not? Likewise, ask yourself how the game would work without this feature. Now, let's talk about how this can be implemented in Godot 4. First, a quick disclaimer. The method shown here only works in Godot 4. Between Godot 3 and Godot 4, there are strong differences in how to deal with a skeleton. To follow the tutorial, you need a 3D model of your choice that already has a skeleton. For this demo, I use Ryan from my game. To test our changes later, we create a small test world for which we simply take a CSG box as a floor. Important here is not to forget to turn on the collision. We also add an environment and a light source. Step 1. Inverse kinematic setup for character. We start by instantiating the scene with the character. In my case, I take a character body 3D as a base with the base script that was generated. We also add a camera and align it to see what happens later. If we now open the skeleton, we have an overview of all bones available to us in the display on the right. We now add a node 3D to this node setup, which becomes our target for point of interest. I name this node Point of Interest Target. For demonstration and visual feedback, we add a mesh instance 3D below the point, which shows which target we just focused on. Now we create a modification via the skeleton modification stack 3D. In the view on the right, we have to select a new modification of the type skeleton modification 3D look at. In this one, we now have to select the neck bone. In my case, it is the bone 4. As target, we select the node 3D we created earlier. Now you have to correct for your skeleton by means of additional rotation where the head looks. In my case, I need a correction of -65, 0 and 180 degrees. Here, unfortunately, you have to do a little trial and error to see what works best for your skeleton. In order to be able to recognize the point of interest at all, we now create a separate layer in the settings just for those elements. You can name the layer as you like. In my case, I call it simply point of interest. After this layer has been created, we define an area in front of the player by means of an area 3D which should explicitly recognize those points. It is important that we configure this area correctly now. To do this, we remove all entries from the layer and select the newly created layer in the mask. Also, we deactivate monitorable because we never want to recognize this area from another area. For this to work, we again need a simple collision shape, which in my case is a simple cylinder. I rename my area the point of interest area. Now we link the events for those areas we want to recognize. We then add a few print statements to test. Before we implement the point of interest, let's make a few quick changes to the script. At the beginning of the script, we add the following content. First, a constant describing the first modification. In addition, variables that tell if you have a destination for the point of interest and a reference to that point. The other are links to various nodes. Under the already generated code, we now add the following content. In the ready function, we activate the modifications and deactivate point of interest initial. In the process function, we check if we have a target. If this is the case, we test if the reference we have is still valid. This is especially important when the point is deleted from memory. If everything is okay, we change the position of our target to the point of interest. Otherwise, we stop point of interest. Step 2. Create a point of interest. Now we create the point of interest. For this, we create a new scene based on an area 3D. The goal is to be able to add this node to any element later on. We now create a required collision shape in the form of a sphere and scale it down. Now we have to make a few settings for the area. First, we disable the monitoring, because this component should not do this. Then we change the layer to the point of interest and remove all layers from the mask. For testing, we again add the mesh instance 3D in the form of a rod. After that, we add a new script with 2 signals. Additionally, a few functions to trigger these signals programmatically. Step 3. Implement logic to change the point of interest. First, we create a small demo with the character and 2 randomly distributed points of interest. Let's briefly start the scene and see what happens when a point of interest comes into our area. As we see, we receive the elements, which is perfect. Now let's go to the script which we insert with the character. Here would also be the point where you would insert the behavior of the character. We will take a very simple approach here and just take the last thing that was added to the area and take that as the point of interest. First, we trigger the signal, then we start our point of interest implementation. If we now lose sight of an element, we recognize this with the area. By means of the script, we check whether there are still elements which we can take. If this is the case, we simply take the first one from that list. If there is none left in the area, we deactivate point of interest, but only use the animation until we receive an object again. Now we can start the game and see how the whole thing looks. Step 4. Polish the solution. Now we want to improve one element of the solution. Currently it is so that the animation is very jerky. We can now easily improve this by interpolating the position change. For this, we only need to implement the following small things. At the beginning, we need a small modification in the node setup from the player. We duplicate the point of interest target and delete the mesh instance 3D. We rename this node to point of interest initial position. We use this node 3D to return to an initial position when leaving the head turn. In the initial variables in the code, there are new elements which we need. First, we add a new constant which can be used to adjust the speed of the animation. After that, we need 2 more variables. One for the timer to make the linear interpolation. The other one is another boolean that tells us if we are currently stopping the animation. At the end, we add a reference to the new node. In the 2 events for when points come in or out in the area, it needs minimal changes. When we capture a new point of interest, we now additionally reset the timer. When a point of interest leaves our area and we have no more points, we now change the code. We take out the code that stops the animation, but we reset the timer and set the variables so that we know that we want to stop the animation. The last changes that need to be made are in the area where the main logic is. In the area where we have a target, we now count up our timer. If we still have a valid reference, we no longer directly overwrite the position. Instead, we make a linear interpolation to the new position and overwrite or look at target with this position. Additionally, a completely new area is added when we stop the animation. Here we do something similar to what we just did, except that we take the initial position as the target. Now, when we run this, we have a smooth transition when a point of interest comes into view or goes away. Of course, this also works when the point of interest moves. Feel free to try this out for yourself. Here, for example, when I move one of the points using an animation player. That's it. The implementation is that simple, but the effect is very strong. If you have a question, post it in the comments and I will try to answer as soon as possible. If the tutorial helped you, please leave a like. Also, I would appreciate your feedback in the comments on how you liked the tutorial. Since it's my first tutorial, it would help me a lot to make later tutorials of this kind better. See you in another tutorial or devlog of my game. Bye!